Hello and welcome to the session. In today's session, we will be discussing about some of the basic concepts which are related to programming languages. In fact, this relates to Unit 3 of Block 2 or Unit 8 in certain cases, and it covers basic aspects of elements of programming languages, algorithms, flowcharts, looping and decisions, assembler, compiler, and interpreter. Out of these 5 concepts, we will be covering elements of programming language, algorithms, and flowcharts in this particular session. And in a subsequent session, we'll be discussing about some examples. In fact, some more examples. In this session also, we'll be covering one example and then related to other advanced concepts. Well, to do programming, what you should know, right? Well, the very first thing is, if I want to do programming, I'll be taking a problem to solve that particular, through that particular program. Okay, so how to solve a problem is very, very important step when you want to do programming. And in order to write or how to solve a problem, what you write is an algorithm. All right. And how to make program using an algorithm? Well, we use a programming language just like for communicating, we are using English language right now, right? So in computer also, to communicate to the computer that this is what, or these are the steps which I require from the computer, I use a programming language. And there are multiple programming languages computer. So a programming language, it is used to design and describe a set of instructions and computations to be executed by a computer. And we'll study an example today. Okay, and to obtain the output from a program, it must be compiled or interpreted so that computer can understand it. Now, this is a very important step. After all, when you will be writing a program, it will be in a higher level language, which is once again not the computer's binary language. So the program is to be converted into computer's binary language, and that is done with the help of a compiler or interpreter. Right. So you need to write program in a higher level language. But from where we need to start? It is the problem. So a problem is basically carrying out a particular task. So you're given a task, we take it as a problem, it is to be solved or it is to be addressed with the help of a computer program. So to solve the problem, input must be given to the system. The system will do processing on that particular input data, manipulate it and produce certain desired output from it. So this is the way a problem is addressed by a particular computer. So what we generate for solving a problem is an algorithm. Well, an algorithm is a procedure or process designed to produce the required output from the given input. That is exactly saying the same thing. And the important thing is computer is a machine that does not possess problem-solving judgmental capabilities. Therefore, we are responsible for doing this particular activity. Although these days you have heard about AI and other things, but AI also start from data which is being provided by you, intelligence which is being provided by you. And after that, lot of reinforcement and other kind of learning is given so that computer can behave more intelligently. So ultimately, we are responsible at some point of time for making computer more intelligent. And so for any kind of a problem solution, we might be writing program. Now this is about basics of programming. So you need to write the basic of those program with the help of algorithms. Thus, the procedure must be designed using a sequence of simple and unambiguous steps. right? So this is a very important property when we are designing a programming or an algorithm for a computer. Why? The steps have to be simple and unambiguous. Okay. Now what that means, there has to be some features of the algorithm, and those features are that it must be organized logically and clearly, so that program implementing algorithm is well structured. So whatever program you will be using to implement the algorithm, it should be a well structured program. All right, then only your program is going to be reusable, and it may be easier for or faster to execute. So number of steps in algorithm should be finite. So this is another property: unambiguous, finite, simple, then executable in finite amount of time, that is once again finiteness only, and should give the desired output. So correctness, that is like it should produce the correct output also. It should not produce the incorrect output, which right now we are getting at many places when you are utilizing some of the newer kind of AI based technology. Somewhere you might say, oh, this may or may not be correct, kind of a thing. Okay, but we are talking about simple programs right now. So what are the ways of basically organizing, okay, or sequencing an algorithm is concerned? So the instructions in an algorithm, most of the time they are going to be sequential. That is, steps are performed in strictly sequential manner. First step, second step, third step, and so on and so forth. So that is step-by-step execution, sequential execution. Okay. So where exactly this will be required, we'll see an example of that. Then comes the decision and selection. Now, decision and selection in many cases is very much required, and we will take an example of this particular situation also, where we choose one of the given option, right? Okay, so one of the several alternative action is selected or executed. So this is what decision is all going to be all about. And then we will be going for repetition. So repeating some of the task again and again, right? One or more steps are performed repeatedly again and again. For example, if we are computing income tax for a number of people, right? So input data of number of people is there, then we would be repeating those steps of calculating the income tax with the help of a program. All right. So let's try to see this everything with the help of an example, and that will make it easier for us to understand that. So the problem statement. Now this is a very typical problem, which is normally a very elementary problem to determine whether a given number is even or odd, right? So suppose I want to find out that given number is even or odd, and what is the algorithm for that? That is listed below. Okay, so what is an even and odd number? We all know even and odd number, right? So now the question is how to determine a given number is even or odd. And we all know that if a number ends with 0, 2, 4, 6 and 8 is even, right? But how do I convert this particular knowledge into computing knowledge? And for that, I need to write an algorithm. So algorithm always starts with the start statement. Okay, so step 1 is start the program. Then step 2, we require input the number n. So if I want to find a given number is even or odd, so I have to give that number, right? So that giving that number to computer will require inputting that particular number n into the computer. Then a very interesting statement is being written over here. Find the remainder on dividing the given number by 2. If remainder equals 0, then print number is even, else print number is odd. Now this is a very, very strong statement, very long statement. What does it communicate? Actually, we have converted our knowledge into computer's algorithm by stating, suppose there is any number, for example 223, all right. If I divide this particular number by 2, what will be the remainder? Obviously 1, 23, right? So odd number gives a remainder 1 on division by 2. All right. So this is what is being stated over here. That is, find the remainder on dividing the given number by 2. All right. And if remainder is 0, then the number is even, else the number is odd. So we are taking a decision over here, right? So there is a decision which is being taken over here. Okay. And then finally the program ends. So we have given an input. The output here which is being generated is using the print. Okay. The number is even or odd, and the program ends over here. Now, can I represent this particular graph or this particular algorithm in a even more simpler way? Well, most of the time when you want to represent a graph in a simpler way, you use flowcharts, all right, which is a graphical representation of an algorithm. Which describes the sequence of operations that are to be carried out to solve a problem. Flowcharts are usually drawn using some standard symbols. And then this particular algorithm, I'm so sorry. So a program is a sequence of statements which is written in particular programming language to implement an algorithm on a computer. So let's look into the flowchart of the even and odd kind of the algorithm which we had designed. And the flowchart uses typical symbols. So let's look into this particular symbol. So this represents the oval symbol. Basically, there are two such symbols. One is for start and the last one is for stop. All right. So this is basically start and stop. So start and stop, you use symbol, these ovals. Then you have the parallelogram. This parallelogram is basically used to represent input and output. So what was the input? The number n. So this particular input is being represented over here. That is input n. Okay. Input a number n. Okay. Then this over here, what you are doing? Print number is odd or print number is even. These two print statements we have issued, right? So these two print statements are also, these are output statements. So input and output are represented using parallelogram. And decision making, that is if, okay. So what we are checking? If remainder equals to 0, okay. So what we are doing here? If n remainder operator by 2. So there has to be certain operators which must be defined, okay. So we want the remainder on division by 2 if equals 0. There are two equals here because that is equal to, that is defined by two equals operator in most of the programming languages. Therefore, it is being checked over here. That is, if the remainder is 0, the answer can be yes or no. Okay. On dividing by 2 this particular n, the remainder, if it is 0, if answer is yes, then the number is even. So that is what is going to be printed. And if answer is no, then you are printing that the number is odd. So that is how you are able to design your program with the help of decisions. All right, we have not discussed about looping so far, but this is decision making. Now, how to write program for this particular thing in a programming language? Well, for that you need to know some concepts. And those concepts are basically the elements of programming languages. These concepts are the concept of variables, constants, data types, array, expressions, and function. So let's look into the very first concept. Variables. Okay. These are symbolic name given to a memory location composed of name, attribute, reference, and value. Attribute means the type of a value that variable can hold. So this, assume that this is your memory. Okay, and these are your cells of the memory. So either there are going to be certain reference to these particular cells, okay, or you will have name of this particular cell. I can name it X, Y, I, J, whatever, right? So these cells can be named any of those names and I can use them in programming language. So these are variables. Obviously, these cells will be holding on to some different types of data. Like some may hold integers, some may hold the character. Okay, so that is what we are defining the attribute as. All right, and it may contain some value. All right, so a cell may contain some value. Okay, then comes the constant. So constant identifiers that are used for values which cannot be changed, such as numeric constant, string constant. A very simple example of numeric constant can be the value of pi, all right, which is basically 22 by 7 or 3.14, and you can use it in many different places when you are doing the programming. Now, it is the job of the compiler to directly substitute the value of constant in a program. All right. So therefore, constants does not occupy any space as far as memory is concerned. They are automatically replaced whenever the program is compiled into machine language. They are changed. Okay. But the important thing is the data type. And this data type, whatever programming language you are using, it is being used. For example, this cell, okay, so identifying the type of data that can be held in a particular cell, that is the important aspect in many programming language. And some of the data types are integer. For example, cell 1, suppose I name it N, so it can, and give it a type integer, then it can hold only integer type, this cell 1. Similarly, for real number, I can use, suppose real number require more bits, okay. So maybe 2 cells are required, so cell 2 and cell 3 may represent one floating point number, okay. So real numbers are basically represented with the help of floating point numbers. Then character. So these, for characters you have the character representation like ASCII or Unicode. So for characters you can use the character representation. Okay. Then comes operators. So operators can be arithmetic operator. Just like I said, I was talking about the remainder operator. So other arithmetic operator can be addition, subtraction, multiplication, division, and so on. Then there are relational operator. When we were talking about two equals, like equals, is equal to, right? Is not equal to, right? So basically they are trying to relate two values, all right? So that is why they are relational operator. They are trying to find out if a value is greater than other value. is same or equal to the other value, is less than another value, all right, and is not equal to another value. So all these are basically relational operators. Then comes the logical operator, which basically are connectors, and they connect more than two relational expressions. Okay, so two conditions can be checked together with the help of and, or, like that. Okay. Then we have expression. So where we have combination of variables, constants and operator written according to the syntax of a programming language. So we would do some very simple thing when we are dealing with the programming language. Lastly, but not the most, we have not discussed about arrays in this particular session. We'll be discussing about arrays in the next session, but function. Function is basically to repeat a statement or group of statements at several points to accomplish a particular task. So we can repeat those tasks again and again. We use the statement in a program. So repeating the same statement in a program each time makes a program lengthy and reduces readability. So for that we use the functions. So now let us look into the program related to the algorithm or the flowchart which we had developed for even or odd number. So this is a programming language which is being used as C programming, but it does not make any difference. You can use any other programming language. However, in C, the very first statement is include stdio, standard input output dot header file. Now this basically is a typical file which is required. So this is requirement of C programming language, where in definition of inbuilt functions are stored. So if I want to use input, so unfortunately C does not have any statement for input or output, right? So we use functions for input and output, and for that we use standard input output dot header file, which basically stores the basic functions, such functions. And these two functions we are using here, printf and scanf, these are the C functions which are basically designed and stored, their declarations are stored in this particular file. And even if whatever programming you use these days, the libraries, using of libraries are very, very important. They have different syntax about use of library. So it is a kind of library. All right. Now here this is the main function of C language, which is enclosed into two brackets. So this particular basically marks the beginning of block, and this is the end of the block marker. And over here what you see is, here is the declaration, which basically attaches n to a value int. Int basically refers to integer in C. So basically what you are saying, that the data type of variable n is of integer. So n has integer data type. The next statement is a function which is basically will be required to print the information on the screen. So what does it do? It will simply say, it will prompt you printf. The name of the function is printf. So it says enter the number. So it is just prompting you to enter the number onto the screen. And then a statement is there, another function is there. It is not a statement, it is function scanf. Scanf will read it from the screen, and basically this is the syntax. You don't have to worry about the syntax of printf and scanf, but these two are the functions basically performing the job of input a value n. So it prompts you input the value, and it basically accepts that particular value. Now in here, this is percentage. This is basically the remainder operator. So what we are doing when we divide the n by, we perform this remainder operator, it will give a remainder 0 or 1. So here we are checking equals, right? That is, if this remainder by dividing by 2, whatever n by 2, that is going to give me a remainder 0 or 1. All right. If it is equals to 0, whatever remainder I am getting, print, that is once again the print function, that is number is even and this number is even. So this percentage d will be replaced by n, whatever number which you have input. Otherwise, it will print that this particular number, whatever n you have given, percentage d will be replaced by it. That is how this function work is odd. So this is how the even or odd will be marked, and that is the end of this particular block. So you can see that it is one of the easiest way, like converting a program into converting an algorithm to program is something where you need to know the programming language, and programming language is something which you got to learn, because different programming language have different features, different libraries, right? So first, two things which you need to learn as far as programming is concerned. The first thing, you should be able to design an algorithm. If you are able to design good algorithms, ultimately you will be getting good program, and definitely good program has certain features like unambiguous in nature, correctness of this thing, simple, all those kinds of things. All right. So what we have discussed in today's session, let us sum up that we have discussed about basics of algorithms, flowcharts and program. We have given only one example so far, but in the subsequent session, next session which we may have next week, we might do some more, some more examples we will be covering over there, right? And we will be covering some more aspects of programming which may be useful for you. For the time being, bye for now. Thank you so much.